Example 1 says a mine shaft extends down at an angle of 5 degrees. How long will the shaft have to be to reach a vein of ore which is 65 feet directly below the surface? And so we have the surface of the ground. We have a mine shaft going down at an angle of 5 degrees, and we're trying to reach a vein of ore that is 65 feet below the surface. And so how long does the shaft have to be to reach this depth? And so looking at angle 5, we already know the length of the opposite side of this triangle, and this is a right triangle, by the way. We know the length of the side opposite, and the length of the shaft is going to be the hypotenuse, right? That's the side opposite of the 90-degree angle. And so that means that the sine of 5 degrees will be equal to the opposite side, which is 65 feet, divided by the hypotenuse, which is the length of the shaft, s. And so we're trying to solve for s. S is currently in the denominator. We don't like that. We want to move s to the other side by multiplying both sides by s. This way they cancel over here, and we get s times the sine of 5 degrees is equal to 65 feet. Again, we want to solve for s, so we're going to divide both sides by sine of 5 degrees. And these will cancel over here, and s will be equal to 65 feet divided by the sine of 5 degrees. And so we have 65 feet divided by the sine of 5 degrees, and we get that the length of the shaft, s, is equal to 745.8 feet. So the shaft would have to be 745.8 feet long in order for us to reach a depth of 65 feet while we're declining at an angle of 5 degrees.